Hi everyone, in this video we are going to discuss about the first theorem from the geometry of circles. The theorem says that central angle is double the size of any inscribed angle in the same segment. Now I have a sample circle in the diagram where you can see that if we take AB as an arc and if we draw the central angle and let's denote the angle AOB as 2 times theta, then if we take another point on the same segment, in this case it will be the major segment, the center is located in the major segment. So if we pick another point on the circle, let's say point C on the same segment, that means the major segment, then the angle ACB will be half of the angle AOB. In other words, the angle AOB will be double the size of angle ACB. That is the theorem. And that's what we have to prove here. Now to prove the theorem, I am going to draw another circle with some construction here. Let's suppose you have a circle like this with center at the point O. And let's suppose we have picked an arc, like a minor arc on the circle. The arc is AB. And from there we have drawn a central angle. So the angle is angle AOB. And then let's suppose we have picked a point on the same segment, and the point is C, and we have joined AC and BC. So now we have an angle which is the inscribed angle, and that angle is angle ACB. Next, what I'm going to do, I'm going to draw a little more construction here. I'm going to join C with O by a straight line, and I'm going to extend that line a little bit. So let's suppose CD is that line which goes through the center O, and it kind of looks like this. Now if you think about the triangle CAO, that is an isosceles triangle because OA is equal to OC and each of them is equal to the radius of the circle. So OA is a radius, OC is also radius. That means that is an isosceles triangle. And because it is an isosceles triangle, think about the angle OCA and the angle OAC. They will be equal, and let's say that is alpha. So let's assume that each of those angles is equal to alpha. Next, let's look at the triangle CBO. CBO triangle will also be an isosceles triangle because OC and OB, they are also equal to the radius, so each of those sides would be equal. So that will be an isosceles triangle. That means those two angles, the angles OCB and the angle OBC, they will also be equal. Since it is an isosceles triangle, the angle OBC and the angle OCB, they will also be equal. And let's call it beta. Let's suppose each of those angles is equal to beta. Now, if you think about the angle AOD, that is an exterior angle for the triangle OAC. That means it will be equal to the sum of the two farthest angles, that would be alpha plus alpha. So angle AOD will be equal to 2 times alpha, because we know from the properties of triangle that an exterior angle is equal to the sum of the two farthest interior angles. In this case, the farthest interior angles would be angle OAC and the angle OCA. Each of them is equal to alpha. So here angle AOD will be equal to alpha plus alpha, that will be 2 alpha. Similarly, if you think about the angle BOD, that is an exterior angle of the triangle OBC. So from triangle OBC, if we think about that exterior angle, it will be equal to the sum of the two farthest interior angles, that would be beta plus beta. So angle BOD will be equal to 2 times beta. So now if we think about the angle AOB, it is actually the sum of 2 times alpha and 2 times beta, and that can be written as 2 times alpha plus beta. And now if you think about the angle alpha and angle beta, so in place of alpha, can we write the angle ACO? And similarly, in place of beta, can we write the angle BCO? Of course, we can do that because angle ACO is equal to alpha and angle BCO is equal to beta. So in place of alpha and beta, I have written angle ACO, and in place of beta, I have written angle BCO. So then angle AOB now turns out to be 2 times the sum of the angles ACO and angle BCO, and their sum is essentially the angle ACB. So we can call it as 2 times angle ACB. So essentially you can see that angle AOB is equal to 2 times the angle ACB. Now what is angle AOB? Well, that is the central angle. And what is angle ACB? That's the inscribed angle. If you look at the original diagram, angle AOB is equivalent to 2 times theta and angle ACB is equivalent to theta. So looks like the central angle is actually 2 times the inscribed angle. I hope the first proof was clear. Next, we are going to take another scenario. As you can see in the diagram, here we have a scenario where AC intersects OB. In the previous diagram, AC did not intersect OA or OB, but in this diagram, I have picked the point C in such a way that when I join A and C, the chord AC would intersect OB. In this case also we should be able to prove that the central angle is double the size of the inscribed angle. Here the central angle is angle AOB and the inscribed angle is angle ACB. So we should be able to prove that angle AOB is in fact 2 times the angle ACB. First, let me give a name to the point of intersection of AC and OB. Let's call it point D. Next, what I'm going to do, I'm going to join O and C because we're going to need that to do the proof. So let's join the point C with the center. Now if we look at the triangle OAC, we can clearly see that OA will be equal to OC and they will be equal to the radius of this circle. That means that triangle is an isosceles triangle. So the angle A and the angle C for the triangle, they will be equal, which means the angle OAC will be equal to the angle OCA, and let's suppose that that is theta degree, right? Next, let's assume that angle BCD is equal to alpha degree. And now if you think about the triangle OBC, that will also be an isosceles triangle because OB will be equal to OC, which is equal to the radius of this circle. So angle OBC and angle OCB, they will be equal. Now what is the angle OCB? Well, that is looking like theta plus alpha. So angle OBC will also be equal to theta plus alpha, and I have noted that in the diagram angle OBC is equal to theta plus alpha degree. Next, I am going to assign a variable for the angle BDC and the angle AOB. Let's suppose the angle BDC is equal to x degree and the angle AOB is equal to y degree. Then clearly we can see that angle ODA will also be equal to x because it is vertically opposite to the angle BDC, which is equal to x degree. So angle ADO will be equal to x. Now let's look at the triangle BCD. The sum of the 3 interior angles there will be equal to 180 degree. And from there, what would be the value of x? Well, x can be written as 180 degree minus 2 times alpha minus theta. I simply kept x on the left hand side and brought everything to the right hand side. So x is equal to 180 degree minus 2 times alpha minus theta. Next, let's take a look at the triangle OAD. There again, the sum of the 3 interior angles would be equal to x plus y plus theta, and that will be equal to 180 degree because we know that sum of the 3 interior angles of a triangle is equal to 180 degree. So from here, what would be the value of y? Well, if we keep y on the left hand side and bring everything else to the right hand side, we can write it as 180 degree minus x minus theta. And in the next step, I am going to substitute the value of x. So wherever we have that x, I am going to use the value of x that we just derived in the previous step. So that's what I have done here. In place of x, I have used 180 degree minus 2 times alpha minus theta. Now if we remove the parenthesis, this is going to look like this. It will be 180 degree, then minus 180 degree plus 2 times alpha plus theta, and also there is a minus theta. And now guess what? This positive 180 degree and negative 180 degree, they will cancel out each other, and also the positive theta and negative theta, they will also cancel out each other. So we are going to be left with just positive 2 times alpha. So we can see that the value of y is equal to 2 times alpha. Now let's take a moment and see what is y. Y is actually the central angle, which is angle AOB. And what is alpha? Well, alpha is actually the inscribed angle, which is the angle ACB. So looks like the central angle is equal to double the size of the inscribed angle. I hope the proof is clear. This brings us to the end of this video. In the subsequent videos, we are going to prove a few more theorems from the geometry of circle. Thank you for watching. See you in the next video.